All right, now we've been talking about exponential equations and exponential functions. There's also something called logarithmic functions. We've also talked about inverse functions. Well, an exponential function and a logarithmic function, if the numbers match up, then they are inverses of each other. They do the opposite of each other. So one of the things, as we work with logarithmic functions and exponentials in this section, or in this chapter, we need to, a skill we need to have is be able to convert back and forth. Take an equation and get it into, from exponential form to logarithmic form and back again. So this one, I haven't explained what logs are, hardly at all yet, so but that's okay. So this one, the base of the exponent becomes the base of the log. And then the other two numbers sort of switch places, as it were. That is it. We'll do more of that in just a moment. But first, let's see how to put that in the calculator. Now, this is read log base 5 of 25 equals 2. So log base 5 of 25 equals 2. Okay. Now to get the log, we'll go, I know there's a log button there, but that's not the only one right now. So we'll go alpha, window, and then notice option 5. And there are other ways to get it. And let's see, in that lower box, my problem said put a 5, and in the upper box, put a 25. And that should equal 2, and indeed it does. Okay, so I know I've converted it correctly. Let's talk about this some more. First of all, there is no multiplication over here. This has absolutely nothing to do with multiplication. This is a function, log base 5. Another function is log base 6. Another one is log base 13.2. Those are functions. The 25, that's what I'm plugging into the function. Kind of like saying, hey, I've got f of x equals 2x plus 3. And so what's f of 25? And so I plug in the 25 for x, blah, blah, blah. But that's what I'm plugging into the function. Well, I'm doing the same thing here. I'm plugging 25 into the function log base 5. Okay. Well, on this problem, it might look like, well, what the heck, what could possibly be the point? Well, the point is, a long time ago, you had things like 13 to the x equals 4, and was like, okay, so 13 raised to what power is 4? How do I solve for x? I don't know. I can't take the xth root because that's indeterminate. And so we could say, well, this is log base 13 of 4 equals x. Now, x is isolated, which is what we want. And then you can do alpha window 5 and plug that in. Get your answer. So that's kind of the idea there. How about this? 4 cubed is 64. So we'll get log. The base of the exponent becomes the base of the log. And then these two guys switch places. So log base 4 of 64 equals 3. All right. What about if we had something like log base 8 of 2, of x equals 2? Okay. Okay, so to convert it back to logarithmic or out of log form into exponential form, the base of the log becomes the base of the exponent, and these guys switch places. And so x is 64. You'll want to practice converting back and forth a bunch so it becomes automatic, okay? A knee-jerk reaction, like a politician raising taxes. It's just your instinct. Okay, so now we're going to evaluate these. We've kind of already been doing that. Now they set these up so that you can do them by hand without a calculator. So the numbers work out nice, although it probably doesn't look like it on this one at first glance. Okay, so we want to get, but you can always double check it on the calculator and that's fine. But we want to get this guy here to be written as this number to a power. Well, I know that 1 over 81 can be written, well, 81 can be written as 3 to the 4th power. I know that because I'm a math nerd. Okay. And I could write 1 over 3 to the 4th as 3 to the negative 4th. Bring it up top, changes the sign of the exponent. And when these guys match, your answer is just the exponent. Okay, as it turns out. And again, I want you to be able to do it by hand, but I know you're going to do it on the calculator a lot, and that's fine. Okay. Let's see. Let me find one that I really want. I mean, something that's going to really fill my heart with happiness and glee. Sure, this one looks good. All right. Now this time, there's no base of the exponent. So when you don't see it, it's log base 10. Okay. It's kind of like saying, hey, 3x. Well, what's the well, I meant base of the log. I didn't mean base of the exponent. Sorry. It's kind of like saying 3x. Well, what's the exponent? Well, it's 1. Well, do you write it? Not normally. Same thing here. Log base 10 is the most common, or one of the 2 most common logs. And so, we just don't typically write the 10. You can, but you don't have to. Okay. So now for the sake of explaining this, I am going to do that. Okay, so log base 10 of 100. So let's write the 100 as 10 to a power. Well, I know that 100 is 10 to the 2 power. And since these guys are the same, the exponent turns out to be the answer. You check it on your calculator, and everything in life starts going your way. Okay, so for this one, graph the log function, plot 2 points, and then draw the asymptote. All right, let's start on this one with just going to the calculator and see what it looks like, because the calculator draws so much better than I do. All right, so it was 4, and then log base 1/2 of x. So alpha window 5, 1/2 of x. So there's our function. And if we look at the graph, it looks about like that. Okay, cool. So that's about what we're expecting. And it's just going to keep curving over, and it's going to go infinitely far down and certainly up. And it's also going to go infinitely far to the right. So that's roughly what it looks like. And we're supposed to plot a couple of points. Let's just grab a couple off of here. How about that? Oh, look at this. I plug in negative numbers, doesn't work, or 0. Those are outside the domain of the standard log function. All right, so how about a couple of points, like 2, -4, and 4, -8? Let's do those. Okay. All righty. Let's see, I want this. I want that. Okay. And then I'm going to want, let's see. Oh, whoops. Need to click on this. So it was, just to be clear, 2, -4, 4, -8. Yes. Okay. Just want to make sure I got that correct. Okay. And then that's -8 right there. And that's -4. So now I get to do my cool little x again. So 2, -4 and 4, -8. And with only 2 points, it's a little tricky to do it, but just eyeballing it. But it turns out if you know it's a logarithmic function, 2 points is enough. Okay. And so it's going to look roughly like this. Okay. All right, so that's the graph. Now, it does say, oh, and draw the asymptote. What the heck is that? Well, I'll tell you what it is. All right, the asymptote is a straight line that helps govern the extreme behavior of the function. So you'll notice that around here, the function just keeps getting closer and closer to the y-axis, and it never touches. Remember how when we looked at the table on the calculator, and when x was 0, y was error. It's because the function never gets there. It gets closer and closer, but it never gets there. And so the asymptote is going to be that y-axis. And we typically represent asymptotes with dotted lines. It's just tradition. And so it's not something that actually graphs. It's just this kind of this boundary, okay, kind of like you have an invisible doggy fence. All right, that's really how it goes.